Almost forgot. Okay, so complex analysis reading group. Why isn't the chat blank? Oh, that's just a weird thing with how the... I'm using a different thing to display the chat now because I'm also showing the YouTube chat. And for whatever reason, it doesn't wipe the chat between streams. So yeah, that's just a weird thing. Oh, okay. You know what? This is completely off topic, but I just ordered a pop filter for the mic. Like that thing there. And I try to avoid ordering things from Amazon to the greatest extent I can. And so the place I normally order Slim. Thank you so much for the raid, Slim. I hope your stream was good. If you're gonna see my end, check out Slim or Academy Visa Ideas. He's awesome. Hey, Fembox. Yeah, I was in the middle of telling a pretty stupid story, and then we're gonna get into the reading group. But I just ordered a freaking pop filter for my mic, like that thing there. And I try to avoid ordering things through Amazon to the extent I can. And actually, let me stay on full screen. And so the site that I normally order things is called Sweetwater. And every time you order something, they include a little bag of candy, which is awesome. Initial stream, we didn't finish your problem. You're very close, though. Oh, okay. Fair enough. Oh yeah, I saw you working on an Euler coin project, Euler problem, or like it's like a a made up crypto coin thing. I remember trying that one and I cannot figure it out. But yeah, and so they include candy every time you order anything, and like they included like the type of candy that an old lady would give you at Halloween, like Dad's root beer. Like who the hell even has these? It's probably good. I don't remember the last time I've had one. I think I remember liking them. Bit o' honey, which I think are actually good. But it's still like I don't know where you can buy those. Then the actual this is probably the worst candy. Smarties. Is it gonna focus? There it goes. Yeah, Smarties. Maybe they'll come in handy for the thing that we're about to do though, if they make you smarter. And this is just like a peppermint that you would get like on your way out of a restaurant. No, I haven't eaten any of it. The package only got here this morning, and I haven't felt like eating any candy yet. Oh yeah, it's called let me just bring it up. Sweetwater. They have a bunch of audio stuff. It's a really cool website. They actually have like audio engineers that you can like talk to as well. I haven't found them to be super helpful, but it's so cool that they're available. What's wrong with Smarties? Everything is wrong with Smarties. They suck. But yeah, I didn't say hi to Mouse. Hi, Mouse. I said hi to Mouse. I said hi to Slim. Okay, so I'm sure I'm not forgetting anything. Just a US thing. No Smarties hate on your watch? Really? Like, those things are hard to like. They're basically chalk. Well, like, these are going to be complex integrals. Like complex variables. Okay, so let's actually get into the reading group. You finished the Euler coin one? Oh, okay. So was it a different one? Let's get the actual group started here. I'm going to jump into Discord. Am I on push to talk? I am. Voice activity. Problem summary just submitted. Oh, nice. Oh, okay. That was the problem. Smarties in the US are just powdered sugar pills. Some rates in the UK are yummy, similar to M&Ms. Oh, there's a difference. Okay. White Smarties you can hate licorice. Red licorice can be really good. The stuff in grocery stores is normally like old and grody. Black licorice is just disgusting, no matter what. Am I gonna see Europeans who are smart? Okay, no. Wow, yeah, these are way different. Twitch sound playing not being captured by OBS. Yeah, Poison Mouse. You can't use desktop audio though. Gonna have to throw down about black licorice. Don't let it end this way. You like black licorice?
I love it. I love it. Why would?
Oh no!
I think I got the taste for it from my mother. She likes it.
Okay, yeah. I tried it once or twice as a kid, and it's just kind of gross.
You know, they used to have Altoids in licorice flavor. Oh, they were my favorite thing, but they don't sell them anymore.
Huh. Oh man, that can't be good.
Oh, they were great. God, they were good. I know black licorice, it's like I think it's like either you love it or you hate it kind of thing, and I just love it.
Yeah, it seems like it.
Yeah.
European Smarties are easily a 7 out of 10. Okay. Such as mom also likes black licorice, doesn't mean I gotta turn to the dark side as well.
Well, what about Ouzo? Do they have has anybody tried Ouzo? It's like a
Ouzo?
liquor.
Like UZO?
Oh, I think it's OU, maybe OUZO.
Okay. Let me side my screen in case it says where. In case it says like something weird. Oh yeah, okay, yeah. OUZO. Dry anise. Okay, yeah, anise is like the black licorice flavor aperitif, widely consumed in Cyprus and Greece. Huh.
Yeah, that stuff's delicious too. Although I guess if you don't like black licorice, don't buy it. You won't like it.
To be honest, this tea that I've been drinking has anise flavoring in it, and I've grown to like that. So,
oh well, there you go.
I wonder if I should try it again now that I'm not a kid. But I don't know, with licorice, it's pretty strong flavor though.
Yeah, it's a very distinct flavor, right?
Yeah, Raffaello's in the US. I don't think I've heard of those. No, heard of that. Raffaello's. Porto, like Porto wine? Poison Mouse? I do love Porto wine. I just see restaurants called Raffaello's when I Google that.
Porto, is that the same as port? My dad drinks port.
I think so.
It's like a fortified wine. It's like sweet, I think. Sweeter and stronger than wine.
Yeah, it's like a lot heavier. It's honestly my favorite type of wine that I tried so far.
It is kind of nice. Yeah, you just sort of have a small
like a shot's worth. Yeah.
Yeah.
Does licorice have health benefits? Also, hey Nikhil. I feel like licorice could have health benefits. I don't know though.
Yeah, maybe.
It's usually I usually just see it sold as candy though. Oh, it's a city in Portugal. But I think you can also call like there's Porto wine and maybe even Porto beer.
Oh.
I don't know. One could think that isn't tasty enough to be candy.
I'm sure if you just have licorice like the star anise or whatever without sugar, I'm sure it's probably pretty rough, but you put enough sugar in it, it's
Oh yeah.
fantastic.
I guess it, I'll probably enjoy it if it's like 99% sugar.
Yeah.
There's definitely there's got to be like a critical line there where it tips over into being too much. Okay. Do you want to get into the complex analysis?
Sure. Sure.
Okay, so we're talking about section 2.4, 2.5, and then the first part of 2.6. Although I did skim the entire thing for 2.6. I didn't like read it very deeply though. Most chocolate doesn't have that much cocoa. As in like it's fake or like milk chocolate or maybe both, but I definitely prefer dark chocolate. Milk chocolate? Okay, yeah. So they start by defining integration as just kind of the same thing as, well, honestly, there's so many different types of integrals that we went over. It's kind of easy to get them mixed up, but the very first thing we see is that if you just let f be a function of u and v, you can just kind of integrate u and v independently as normal. And our familiar function theorems, or like the fundamental theorem calculus still holds. We learn about different.
So in that case, the input was a real number. I think that's what they started with.
Right. T is a real parameter. Or a variable. And then, oh yeah, I guess this is why they start introducing like all the stuff with the different types of curves, which I always get these terms confused. But like simple curves, closed curves, continuous, piecewise continuous, smooth. But they use that. Sounds good, Perperba. Hello. Oh, I forgot to do the pin message. Okay. And then they define the contour integral for complex numbers, which looks just like a line integral where you like parameterize it.
Yeah.
Okay, and then theorem 2.4.1. If the antiderivative big F is an analytic function, then you have this like fundamental theorem of calculus looking thing here, where the integral is equal to the antiderivative of the endpoint minus the start point. And it like, this was fine, but then later on, we started getting into things that look nearly the same, especially with like the closed curves. And so that's going to be a source of confusion for me, I think, with like what theorem we're using when or what the differences between them kind of really are.
Yeah.
Hardlocked hate. Focus is the best name ever. It's pretty good. That will take you a long time, hardlocked. You mean seals in Portuguese? Oh, funny. Oh yeah, so there's kind of a neat thing where it seems like there's a relationship between the Cauchy-Riemann equations and like conservative vector fields.
Yeah.
Because for the same thing with the conservative vector field, you know, if you integrate on a closed curve, you just get 0. And it seems like the same thing holds true here, where if you have an analytic function, you integrate to 0 around a closed curve. which it's kind of weird that there is that relationship, but it must have to do with like that partial derivative stuff being equal and kind of being like a substitute for checking what the curl is.
Yeah, that's right. If the curl is 0, that tells us something, doesn't it?
Yeah.
If the curl is 0, what does that mean? Doesn't that mean there's a potential function? Like a
Yeah.
vector potential?
That's like the exact thing we were doing with like the electric field being conservative.
Yeah.
And finding the potential function, I think, is literally just the electric potential from the field. Closed curves are basically periodic functions with complex values. That's interesting to hear, Puika. That would make sense why non-analytic functions have issues with or like they aren't 0 for a closed curve, because you basically step to a branch cut. What's the definition of a conservative field? Just the curl being 0, Slim, right?
And the conservative fields, are they the exact same ones that have like path independence for an integral between 2 points?
I believe so, yeah.
I think that might be true.
I think that's one of the rare times where mathematicians and physicists actually agree. Cauchy-Riemann equations imply the real imaginary parts have 0 curl. Okay. Just scrolling through, they do some examples. If you had a conservative field in dimension 2, you write them as a complex function. Would it satisfy the Cauchy-Riemann conditions? I imagine it would, yeah.
I think so.
Oh, okay. And then on page 76, figure 2.4.4, this thing with crosscuts was really interesting. And it seems like it's a theme that's going to come up a lot. It's kind of crazy that this works, to be honest, for how you deal with a non-analytic point in enclosing your contour.
Again, I feel like we did something similar to that in that Purcell Morin book, didn't we? I feel like we did something like that. Yeah, I think we did.
Oh no, I think
maybe
it was the wrong one.
I think it was, but it wasn't in the plane. It was like a 3-dimensional thing. We were taking some flux through some sort of curvy surface, and we could project it down to being like the same flux over a nice section of a spherical shell or something. I think I remember something similar to that.
Oh, I wonder if that is the same. Yeah, so I think it's how they proved Gauss's theorem.
Yeah, maybe it was like Gauss's law or whatever.
Or law, yeah. Where, yeah, they talk about, like, I remember they kept using the word balloon, but it could be like a really weird shaped balloon. And they proved it's the same thing as a sphere, so you don't need to do any crazy, or like, the shape doesn't matter as long as it's smooth.
Yeah, and I think it was the same idea of like deforming some kind of a region to make it look like a nicer region to work with.
Oh my god, yeah, and these contours, by definition, are analytic and have to be smooth also. I didn't think about that, but that might just be the same exact idea. Huh. Okay.
It's a pretty sweet trick, isn't it? Like taking that loop and then like cutting into it into a little circle and then like taking the limit as you let those two branches like come together. It's pretty cool a trick.
Yeah, it sure feels like it shouldn't work, but apparently it does. Like, it just feels like a different situation to me, but in the limit, it would just become it would become like a full loop around, so.
What do they call that in the book? A crosscut?
Yeah, crosscut.
Crosscut, yeah.
The L1, L2 thing.
Yeah, and the L1, L2 are like little bridges that cancel each other out.
Yeah, and so I was interpreting that as like they cancel each other out because they're going to get like very close together and they go opposite directions, so they're essentially integrating on the same path.
Yeah.
That's kind of how I thought about that. Okay.
And then he got back into his fluid flow there again for a second.
Yeah, I don't remember saying anything that important though in this part. I also do a ream on some definition for these as well. Kind of randomly at the end here, they define this simply connected region thing. But I think it comes up in the next section. Okay, so what happened in 2.5 then? Because that was the end of 2.4. They introduced, or they just kind of remind us what Green's theorem says. Which is another thing that requires the curl to be 0. So there definitely is a relationship there.
Yeah, and look at that Green's theorem, 2.5.11. And if you
2,
think
5, 1?
about that, oh, was it 2.5.1? Yeah, 2.5.1. And yeah, so the double integral over the region, the integrand is Vx minus Uy, isn't it? And so if the Cauchy-Riemann equations are satisfied, isn't that just 0? Vx minus Uy. Let me remember that.
Ooh. That might be the one with the negative.
No, is it? No, that's not 0, is it? That's the opposite, yeah. Because those are supposed to be opposites. Because I was looking at this today and trying to work out if I could use the Cauchy-Riemann equations on it. I think both
this
the
has to be
signs
for
are
a closed curve, I think. Right now, when we're talking about just about Green's theorem without any complex stuff yet. Does Green's theorem have to be around a closed curve? So we'd want non-analytic.
Reading some of this.
Okay, sorry.
I was reading some of this today, and I think I was getting confused at points between, stuff from Calc 3 where we were just learning about, like line integrals and things like that, and then complex integrals where you have eyes everywhere.
Mm-hmm. Okay, yeah, Green's theorem only applies to closed curves. Oh, I mean, I could have just looked at the book's definition too. Vx, I believe it is minus Uy. Yeah, so it wouldn't be 0.
No.
But then what they do this because they want to prove Cauchy's theorem 2.5.2. If the function is analytic, then, and so this is the function that you're integrating is analytic, not the result of the integral is analytic. That's the first thing I got confused on with the thing we saw in 2.4.
Hmm.
Um, UDX. I was comparing with. Oh, okay. It's not 0, but I think because now in the complex case, it's u plus iv. You get two different integrals that you can then like mix and match. I don't know. Vx uy ux vy. Why does it match here?
So I guess they used Green's theorem twice there.
Yeah.
And then everything just cancels, does it?
Yeah, for whatever reason it works out here. I don't know why it didn't work out. Oh, I think because of the dz equals dx plus idy substitution. That flips some signs. That might be it. Bluebird is saying f is conservative if it is the gradient of some scalar function f.
Yeah. See, it feels like it's missing the I that we need, right? Like if instead of like x plus y squared, it was x plus iy squared, then the Cauchy-Riemann equations would be satisfied.
Hmm. I'm not sure. This is worth Googling.
Yeah.
Conservative vector field have zero curl. Hey, Obi. I wonder if it could be a one directional implication, like zero curl is always conservative, but conservative isn't always zero curl.
Yeah. Wasn't that where it had to be a simply connected region or something? I remember
You're exactly
seeing
right.
something.
Yeah. A conservative vector field is irrotational. Oh wait, I had it reversed. Any conservative vector field has zero curl, but the converse is true. Hey, Ashu. So curl f equals 0 implies conservative is only true if it's simply connected. Hmm. Oh, well, this second change answer has a really interesting example.
Hmm.
With the flying potential A defined in some region, and they just show like a heat graph. The associated vector field F equals gradient A. It's like that, just a straight up like rotational field, not sink, like no sinks or soars. Since it is a gradient, it has curl F equals 0. That field has no curl? That's kind of crazy. Oh, I can kind of imagine that if you draw a little box though. We can complete it into the following still curl free vector field. This vector field is curl free but not conservative because going around the center once does not yield 0. Because it's not simply connected. Wow. Because it has a hole in the middle, that's the issue. Yeah, in like 2 hours or so, I will. Okay, this is a good... I like this example.
What if you took that example and continued it and sort of continued it to the center? So you, instead of it, what would happen right at the middle? There'd just be like some kind of singularity.
I guess so, yeah. You have like a zero vector issue. Okay, see ya, Aditya, sorry. Yes, that one I guess would be difficult to define if you brought it all the way to include the origin. Okay. Um, but yeah, I think here for Cauchy's theorem, it works out because of the eyes that are involved. Because you do substitution for f of z and for dz, and so you're gonna get some I times I stuff that happens, and I think that's what saves it. And then there's theorem 2.5.3. If fc is continuous in a simply connected domain D, and if every contour integral is equal to 0, closed contour, then there exists a function big F of z that is analytic in D, that is the antiderivative of small f. The proof for this one was kind of funky. They have 3 kind of arbitrarily chosen points. The thing that I really didn't understand was... Oh, wait.
It's like they're trying to build a difference quotient.
Yeah, there's a part of I couldn't understand this piece of the proof that I'm showing on the stream, where I don't know how they figured out the first equality. without using that it's analytic, because I think that's the point of the proof, to show that it is analytic.
Yeah, what's the capital F? They defined it in terms of an integral, didn't they?
Yeah, it's the result of the integral of small f. Oh, just like a regular integral, though, not a line integral. Is that why this is okay? Oh, maybe I forgot. Oh.
And z0 is fixed.
Oh, I get it. Okay, so I had to look at the definition again. Okay. This makes sense now. Yeah, z0 is fixed. Regular z is the variable. Oh my god. Okay, that makes so much more sense.
I don't think we're ever really going to have to use that theorem.
It does seem like, how do we ever know that every closed contour is going to integrate to 0? That seems like a hard thing to show. I think it comes maybe in a proof that's later on or something, but we probably won't have to apply it to solve a problem.
I kind of hope not.
Oh my god, yeah, it got a little bit crazy after that with the domain with multiple holes in it, and you make a crosscut for each hole.
Yeah, just keep doing the same thing.
And you can prove that the integral around C0, the border of the entire domain, is equal to the sum of the contours around the smaller holes. Which is just weird to me that would be true. But it's just extending the thing that we saw the last time, which even then still feels weird in just like the simpler case with just one hole, that those two curves would integrate to the same thing. But yeah, deforming contours, I guess. It's a thing.
Okay, this example you got on screen now, 2.5.1.
Yeah.
I was looking at that one today, and I was trying to work it out, and I got it wrong. And the reason I got it wrong is because I don't think I understood the definition of the boundary of the annulus. They said curve C is the boundary of the annulus between those two circles. And if you look at the picture they gave, figure 256, both of the circles were being oriented counterclockwise. But then when they do the problem, they say, well, actually the boundary isn't C1 and C2, it's C2 and a negative C1, they said. So I think I was doing the wrong sense on the inside circle. And so I don't know. I think I was trying to read about, like, how do you define, when you're doing some kind of a contour integral in the complex plane, how do you define the boundary of your region? And I think what I read is you always got to, if you imagine going around the boundary, it's like your right hand. I think your right hand has to be on the boundary as you walk inside the region.
No, you can look to your left, and that's the inside.
Yeah. You look to your, so if I'm inside the region, like my right hand is on the wall and I look to my left, and I'm inside the region. So I guess does that make sense? So I guess that's why you have to do the C1 as negative C1. But I thought that was tricky. They kind of tricked me there because they drew the arrow of C1 going the other way.
Mm-hmm. In other figures, even in the one like right above it, they were careful to do that. Or like to negate them when there's the crosscuts. Hey Sandcall. Hey Lucas. Yeah, a lot of people have tried. Hey Famished. Oh nice. Psychology. Yeah, so I was also really confused about what the boundary of an annulus actually is. It makes more sense if you think about it with the crosscuts, but like it still feels very weird to have two boundaries that are disconnected from each other. um but with
So
it,
I guess if
yeah.
we had a figure like the other one up there where there was like one circle outside and then a whole bunch of circles inside, if we wanted the boundary of that region, we'd have to do the outside one counterclockwise, but all the inside ones would be clockwise circles, I guess.
Yeah, because of those crosscuts.
Okay. Good to know.
I guess you could have also, or we could have also like reversed the direction of the outside one, but that would feel weird. Oh, it was super weird. Another super weird thing about this one is that it, even though it goes around 0, we still don't have to worry about 0 because it's it's not technically in this domain. Like we're surrounding 0, but we're not including 0, so it's not important as a non-analytic point.
Yeah.
It's just weird that would still, like, we wouldn't, I feel like we would have to worry about it, but evidently not.
Yeah, well, the way I was doing it, I was worrying about it because I was going around C1 the wrong way.
Okay. I'm like, famous, you're gonna diagnose me? Better than you have tried. Okay, in the next example, or sorry, were you about to say something?
Nope.
Okay.
No, you're good.
The next example, I'm so confused by what small m is. Is it all of these numbers at once, or do you just choose a particular one? Why can't they just say
I
n?
was more confused by the capital M. I had no idea why that was there.
Well, yeah, I guess
I
it's
think
kind of the same thing.
lowercase
Yeah.
m is just supposed to be a positive integer. I think.
Yeah, and so, but why wouldn't they just put like dot 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 with no big
I
M?
don't know. I was looking at it and saying, well, what's big M telling me here?
Yeah.
Yeah.
Like, does this stop working at a certain point, or I don't know.
I don't know either. I don't think you need it.
Yeah, they don't seem to use
Maybe
it later.
you know what it means? Maybe it means it just has to be finite. Maybe that's why they put that there.
Oh, maybe. Um, and at first this integral seems super random. Like, why would we care about this one? But I would later remember that this is like, I think, related to the residue, which I've heard the name of, but I don't know much about. So I think this one is going to come up a lot.
Yeah, I think so too. What's that little delta? Do you see right on the bottom of your screen now? Delta M1. Is that like the Kronecker delta? Like a sine thing or
Uh,
something? I wasn't sure what it was, but it's some kind of symbol for telling us it's either 1 or 0.
does the Kronecker delta, is that the one that goes to infinity? I don't remember.
I'm not too familiar with that notation. Maybe the M comma 1 means okay, it's a 1 when M is 1 and it's 0 when M's not 1.
Oh, you're right. It is just the Kronecker delta. Oh, so it looks the exact same. Direct delta is the one that I was thinking of. Okay.
Oh yeah, Dirac delta. That's like an impulse function. I remember learning that.
Yeah. And so there's this weird thing where there's like kind of a critical case where m equals 1, but other than that, you're okay. And that has to do with the integral of 1 over z being log of z, whereas for everything else you get 1 over z to a power.
Yeah. Yeah, it's very cool.
Yeah, it's super weird how this one, like, logs seem to be a really important theme for complex analysis in a bigger way than in calculus. Like in calculus, or like in like regular calculus, when you first learn, you just have to remember that 1 over z is this weird case, or 1 over x. But here it seems like we're going to be relying on this like logarithm relationship a lot.
Okay, this is as far as I got with the reading, page 89. This is where I ran out of time today.
Oh, really? Okay.
So I haven't looked at this polynomial question. It looked interesting. A polynomial of degree n with n simple roots.
Yeah, this one seemed weird. Seems like into the Cauchy residue theorem. Okay, that's good to know.
I figured that was what they would do, is they would break it up into some constant times all those linear terms. And it is a log. Yeah, okay.
Like, yeah, the log thing I think is just like a trick. Like you have to notice that.
Yeah, well, they gave us p prime over p, and I was like, okay, it looks like it's going to be a log.
Yeah. But you get this kind of interesting result where this integral counts the number of roots lying inside of that contour. So like,
Oh, I'll be damned. So it does. Oh, because it's 1 for each one inside and it's 0 for the, wow, that's beautiful. That's pretty cool.
yeah. So that's kind of a cool like root finding method. I don't know if it'd be particularly like efficient, but it's cool. Someone's saying that's the same trick he used with Newton's identities. That's why he used the derivative of the log in those problems. What are Newton's
I forget.
identities?
I don't remember Newton's identities. I've forgotten.
That 1 over 0 equals infinity? Or 0 over 0 is 1?
Oh, something to do with symmetric polynomials?
Apparently you and Slim talked about this at one point.
Yeah, my memory is just not good, you know? It's just not good.
Oh, apparently Fizbo suggested it. Okay. This is just a bunch of letters to me. I don't understand what's happening here. But okay.
If you scroll down a bit, it's talking about roots of a polynomial, maybe.
Oh, yeah. Actually, wait. Large text. There we go.
Oh.
I'm still a little lost with what's happening here, but
Yeah, it's not ringing a bell.
okay.
What about the Vieta formulas? Are they anything to do similar with this?
It looks kind of evocative of those, yeah. I don't know if it's the exact same. With like the sum and product of roots. Some says that they're related, yeah. Okay. It is useful to calculate the determinant of a matrix in terms of the polynomial of the trace, which is why Fizbo suggested the problem. Oh, okay. But yeah, that was the end of 2.5 there. I'll
Okay.
just quickly say what like 2.6, the section without stars was pretty short. The main thing to know is they just said what Cauchy's integral formula is, which is that you can, if you have f of z as an analytic function, interior to an honest closed contour C, then at any interior point Z, the function at that point is equal to 1 over 2 pi times a line or a contour integral of this weird f of zeta over zeta minus z d zeta thing for a closed contour. Which feels very random. Like, I'm sure we'll see why this is some helpful, amazing result that I think is a really big idea in complex analysis, but for now, it just feels very weird. I guess zeta is just like a dummy variable.
So you got an analytic function and you divide it by z minus a number, basically. And if you integrate that over a contour around that number and divide by 2 pi I, you get the value of the function. You get the function evaluated at that number. I think that's what it's telling us.
Oh, someone's saying it'll help you calculate contour integrals. So maybe the idea is that we're gonna plug something in for f of z multiplied by 2 pi I, and that's the result of an integral without having to calculate it. It's like the point of this isn't to do the actual integral, maybe.
This definitely has to do with residues, I want to say.
Yeah, the 2 pi I just makes me think of residues. But yeah, that was the main idea for section 2.6 for the stuff without stars. There wasn't too much else that I remember being super important. Actually, there's a bit more stuff than I remember, but I don't know. Do I'm going to get into some problems here?
Yeah, for sure.
Okay. So I chose a couple out of each of the 3 sections, starting with section 2.4. Oh, did I miss getting a screenshot? Oh, no, I didn't. It's fine. If you want to calculate the integral of a rational function p of z over q of z over a contour, you just need to check the residues using that result. Ooh, okay. Oh, because yeah, if you get something like you could partial fractions and get multiple contour integrals added together. Okay, I can kind of see where that might be helpful. For this one, I was saying just do A and C because they looked different.
I think A is going to be easy.
I love easy.
Yeah, me too.
C is the unit circle enclosing the origin. F of z is given as follows. Uh, 1 plus 2z plus z squared dz. And rather than actually calculating anything, we can say this is an analytic function and that it's 0. Is that why it's easy?
I think so, yeah.
Okay, and yeah, doing this even without using that fact would be pretty easy. Like we'd say z equals e to the I theta, and then take theta from 0 to 2 pi, but we don't even need to go that far.
Yeah. Maybe for part C, that's the way.
Yeah, I chose C because I saw there's a z bar, so there's no way that's going to be analytic, or at least I assume there's no way.
Yeah, I don't think it would be. I feel like Z bar is always like a good case of a non-analytic function.
Yeah, I guess I'm thinking of something weirder, like if the z bars can somehow like cancel like z bar over z bar, that could be an analytic. I don't know. You can take the conjugate outside of an integral? That's kind of crazy. Is that true? I had a different idea that I think will be pretty easy, but can you take a complex conjugate outside of an integral? I wonder if you could show that with like the Riemann sum definition. The answer is
Oh, that's
generally
what you
no.
mean.
Huh.
Wait, okay, wait, Slim. Are you saying that the conjugate of this integral is the integral of the conjugate like that? Or are you saying, I think that's what you're saying, right? Like those two operations can commute with each other?
I don't think we even need to go that far, but
If it's me, I'm just gonna write it as x minus iy and just do it that way.
oh well, if it's me, I'm gonna write z conjugate equals e to the minus I theta.
Oh, much better. Thank you. Yeah, that I was doing a couple of problems today where I was going to x and y, and then the book was doing it with polar, and I was like, oh, it's so much nicer.
Is this still gonna end up with 0? Uh oh, it's Zach. Huh. Oh wait, no, I forgot the
Don't
no no no
yeah,
no
don't
no.
forget to
Yeah,
integrate.
I didn't do the substitution right. Because I need to worry about dz. It's like there's no way we're getting 0. Um. Uh. Okay, I can't do this in my head. So we just get a 1/2 out front because the i's cancel. Oh, we're still getting 0 though, aren't we? That feels... That, I mean... Maybe that's okay.
Actually, if you're on the unit circle, 1 over z bar is the same as z, right? And that's basically what you got there.
Yeah, true.
So it's kind of like we're integrating z dz. So it'd be 1/2 z squared, wouldn't it?
Yeah. Um... That's kind of funny. Okay. It's just this one particular contour where it acts like an analytic function.
What?
I think. Because on the unit circle, the inversion doesn't matter. Or at least it just negates the angle, but that doesn't do all that much. And then z conjugate. Well, we inverted the angle twice, I guess. The z conjugate... Wait. Yeah, the z conjugate inverts the angle, and the 1 over inverts the angle. So we just kind of got back to z. I assume if we chose a different contour, though, this wouldn't be the same.
Yeah. Right.
Hmm. Okay. I kind of want to try D now because that. uh,
Okay.
Z times
Oh, I
Z
think I,
conjugate.
yeah, I think I see a shortcut for D.
Okay. Um, what are you thinking?
Isn't what's Z times Z bar? Isn't it just R squared?
Right. Oh,
And if R is we're on the unit circle, that's just one.
yeah. Take away the contour symbol, I guess. Is this also 0? Wait, we're integrating 1 around the unit circle. I guess we could go to complex numbers again. But that's going to be 0.
These are trick questions. They're just all zero.
Yeah, someone's saying it's 2 pi?
2 pi.
Oh, wait. Uh, oh, a constant function is analytic, so it should still be 0. I might have written the integral a little bit wrong. If z equals... Oh, yeah, I should have done this substitution. I made the exact same mistake as last time. It's going to come out to be the same result, but I should have had an I there. Because yeah, we get an e to the I theta times e to the minus I theta, but then an extra IE to the I theta from the substitution. Okay. I do feel a little bit cheated by that. I was trying to choose one that would be like non-analytic, but these keep acting like analytic functions. Maybe it's the unit circle thing. I don't know. That makes it more forgiving. We can just move on.
B's
Oh,
gonna be 0, right? Yeah, because B's got a something happening at one. Oh wait, at one half.
that is contained in it.
Oh, it is,
All
but
right.
it's squared. Didn't we prove that if it was squared, it's still 0?
Oh, E
Yeah, it's only
was
when
like
it's
a
the
challenge. It
one
looks like.
power.
Yeah. So what exactly was that one saying? Um, where is it?
The one with the lowercase m. It's kind of like that, isn't it? I
Oh, is that in 2.5?
think so.
Interesting. This problem's from 2.4, so maybe they want us to like discover that.
Oh, okay, okay.
But I think you're right. Like that would just make the problem a lot faster. Okay, yeah. I think this result would get you this 0 a lot faster, like you say.
Should we try part E, or do you want to move on? I don't know how much time you want to spend on this question.
Uh, we can do E. I kind of skipped it because it has the asterisk, and I was assuming that it might
I
be
know it's
a...
got a star. It's probably hard. E to the Z bar.
The saying to go back to chapter 1.2.19 to use something from that. Oh, these are power series. I'll take a screenshot. E to the z conjugate. Someone's calling that's going to be 0 as well. If e to the z is equal to this, is e to the z conjugate equal to the conjugate?
Oh. Yeah, why not? Seems good.
Doesn't that rely on analyticity? No, I don't remember.
The conjugate of a sum is the sum of the conjugates, and the conjugate of a product is the product of the conjugates, right? I think that's true. So it feels like it should just... So it feels like, so doesn't that mean that, doesn't that mean this? Is that true?
Oh. I don't know.
If I think, well, if we think of it as a series, then it feels like you could do that. Got to put a question mark for now. Yeah, because the...
I'm confused how we would show this.
Well, if I could say that...
Oh,
I think I can say this, right? That's by the conjugate of a product is the product of the conjugates.
Oh, okay.
And then if you divide each one of these by j factorial and then you just add them, then you're just doing a conjugate of sums. It should work.
Confused AF, mean, median, range mode. That's gonna take a little bit too much time for me to explain.
The mad median. Yeah, I was thinking that.
Mad median. Uh, yeah. So I'm not taking questions right this instant. If you can wait maybe like an hour or so, I'd be able to like explain that a bit better. Or if you want, you can like jump in the Discord and I can get back to you. Actually, is there someone who's streaming math help right now that I could send you to? It's just that right now when I'm doing this, I don't usually take questions, but I don't want to leave you hanging. I don't know if they'll be taking questions right now, but I do see Ian Stuckey is streaming. You could try them as well. But if not, either jump in my Discord and I can write you a message, or I can help you out after I do this reading group for another like hour or so. Okay, this still feels a little bit sketchy. So Slomo's saying that he thinks the idea is to switch the integral and the sum.
How about this? Equals... How do we copy this again? Like this?
Yeah, Control C and then... Oh, if you're on the iPad, I'm not sure.
Maybe just hold it. Maybe tap it here.
Sometimes that does it, yeah.
If I just shift it, it takes it away. Oh, there's actions over here. Is this copy? Yeah,
Oh,
I think
hey.
I did.
Okay.
Equals. Now all I want to do is just redo this part.
Poseidon, I'm not sure what black book questions are.
Nope. Now can't I do this?
Sorry, I'm just still playing around with e to the z conjugate.
Okay.
I was hoping to be able to squeeze like, well, oh that, oh
Yeah, it's gonna
yeah,
work, right? Because
okay,
you're basically it's just the I became a minus I, so yeah, I
okay,
think it's good.
yeah, okay. I feel a lot better about this. Taking the conjugate outside of the summation, I agree with.
So then can we even go one more step and say it's this? And put the whole thing like that? Like the conjugate of the integral? I think so.
Oh, why are we back to e to the z?
Well, that was my whole thing. I was trying to get the conjugate out of the z.
Oh, I mean, okay. I don't know if we had to use the series for this though. We could have just done the thing that I wrote down there. But
Yeah,
I
that would've
think we're
been good.
okay. Either way, this I definitely agree with it up to like that step that you wrote, and the next one after that, I assume is okay. I'm not entirely clear on when you are allowed to take the conjugate outside an integral, but
And plus, I didn't put the dz in here, did I?
oh yeah. Oh, wait, you conjugate dz as
That doesn't
well?
look right.
What the hell?
Yeah, maybe this is wrong. Maybe this is. Let's think about this because dz. Yeah, let's think about this.
So Stack Exchange says the conjugate of the integral is equal to the integral of the conjugate with respect to the conjugate of the variable, I guess. I'm not entirely clear on what conjugate dz is, though.
That would be dx minus I dy.
Okay. So, like, we could do, like, a conjugate type of thing if we want to use that property. Uh, Skiller, thank you for the follow. That's what I thought it should be too, Papadoria, but I don't think it is. Finlux is saying that if dz is dx plus I dy, then dz conjugate is the conjugate of that. But yeah, you could also have d and then z conjugate, but I think it's just a different thing. I think. I'm not clear on that though.
I think my last equality here is wrong though.
I think it would be right if we said that. But I don't know.
Maybe it would have been better just to go with what you were doing down here. What if we did this?
Any recommendations for linear algebra? Like, are you just learning it for the first time, key skiller, or like what skill level are you looking for?
This doesn't seem good. This doesn't seem good because we want to go around the unit circle, so we actually want to let x and y be like cosine and sine already. We're going to have like cosine of cosine and sine of cosine and things like that.
Yeah. I don't like that. So yeah, Keyscore, I have read I've read this book and it's okay. I don't have a better recommendation, so if you're just learning for the first time, it's probably the best one that I know of. He also has online lectures through MIT OpenCourseWare, which are also okay, but not great. I don't know of a better place to go if you're just learning it for the first time. Bluebird likes some idea to change the integral and the sum sign, so we're integrating each term. But yeah, I've gone through like on their YouTube channel, I've gone through all of those linear algebra lectures, and there's gonna be some things that you'll be confused on if you're just learning for the first time, but they're overall pretty decent. If you're shooting math streams in general, there's a whole niche of us, by the way. There's a list, and then Slim is also here.
Oh, that's a good idea.
I guess I can see what Lubert is saying, I think.
Yeah. Let's gotta scratch this.
I have kind of a crazy idea.
Okay.
Bluebird's probably the right answer, but what if we considered z conjugate? We're still in the unit circle, right? So just e to the minus I theta And then the integral is e to the minus I theta d theta
Yeah.
from 0 to 2 pi. I don't know if that's too crazy though. Wait, wait. The mistake I'm making every time, that it's actually, this might not be bad because of the substitution. Does this give us an easy U sub?
Yeah, maybe.
I can't tell right now, to be honest, if this is good or bad. So a minus sign, but it's going to be an e to the 2I theta, right? These aren't going to cancel. But that is like a U. Like I said, oh no, this isn't going to be an easy integral. It's going to be e to the U over U squared. So I don't know about that. Oh wait, no. I forgot the minus sign there, didn't I? Isn't this perfect? Wait. Because there's a minus sign in this. No, wait.
I don't think there was a minus sign there.
Because
you're still letting
you're right,
Z
you're
be
right.
regular.
Yeah. Dang it. And this doesn't use the power series at all. So it's probably not.
Well, at that point, you could go and divide e to the z by z squared. If everything you did was legit, it seemed like it might have been okay.
Divide e to the z by z squared?
Yeah, because you were getting e to the u over u squared or something, weren't you? Yeah.
But just randomly divide by z squared? Or I don't understand what you mean.
So I think you've shown that our integral is the same as the negative integral of e to the u over u squared du. So now if you expand like e to the u equals the sum of u to the j over j factorial.
Oh.
And each one will be down, like lowered by 2.
Huh.
And so instead of starting from 1, we'll start from 1 over u squared. 1 over u squared plus 1 over u plus a half. This is probably kind of coming out to what Slim and Lubert were saying, right? It's probably going to give us a different way of doing the same thing. Although I wonder why it was dividing by u squared.
I don't know if I entirely like this. Or even partially, or I might rather go back down Lubert's and Sloane's paths. So the idea was to get the conjugate completely outside of this and then interchange the integral and sum.
Oh, I think the idea was to replace the conjugate as 1 over z.
Oh, on the unit circle because that's okay. Yeah.
I've been using something called OneNote, Microsoft OneNote.
Hmm.
I got pretty good at it. It seems I like it a lot more than Excalidraw for some reason. I don't know why. Excalidraw seems a little fiddly.
It does, yeah. OneNote might have an online version. Like it, we could try that. It might do collaboration. I guess it's something to look into.
So if this is
Um,
right so far, could we argue that like all these like
oh,
Lou was saying, oh,
one of them will not be zero
yeah,
when
but
j
aren't
equals
all the other
one.
ones?
Yeah, all the other
Yeah.
ones should be zero. So this is just 2 pi I, or just 2 pi, or just one. No, I think it's 2 pi I.
I think it's 2 pi I.
Yeah, because integral data is 1 over 2 pi I times the integral, and they got 1. So it should be 2 pi I.
Okay.
All right.
My pen turned red. Oh, that's why. That was harder.
Yeah. I kind of want to check the answer key on this one.
Okay.
This was 2.4, number 1. Um. Oh, they don't provide an answer for E. Unbelievable. They don't provide answers for the ones that I'm actually interested in. I already clicked off. Let me. I want to. Were the other ones 0 at least?
Yeah, I think we got 0
0,
for all the other
0.
ones.
C is 2 pi I. Wait, what? Did we do C?
Yeah, we did see we got 0.
Well, that's not good.
They said it's 2 pi I.
Section 2.4, 1C, 2 pi I. Yeah.
Hmm.
Uh, my thetas were supposed to cancel, and they didn't, apparently.
Oh.
Um, I don't get it though. I don't see the the mistake is somewhere with these two things here. I don't see which one should have the negative though.
No, me either. I don't think either one of them should be negative.
That's the answer for C. Is there a mistake in the book?
Yeah, maybe.
If it was just 1 over z, I think we would get 2 pi I. That makes sense. That's ChatGPT. I'm okay. Can Wolfram Alpha do these?
I have no idea.
Oh, I don't know how to define the contour though. Never mind. Slim chooses to believe that's the answer of E. That makes me feel better, so I'm going to believe Slim, who believes us. Okay, we should probably move on.
Sure. Sure.
Another one from 2.4. I said for this one, just do part A. So C is the unit square with diagonal corners. So if we have... Wait, does the square go all the way... Wait, 1 plus I... Oh, so it's like that and... Okay, it's a square like this. Each side is length 2.
And we're integrating sine z over this.
So...
Well, should we write sine z in terms of exponentials, maybe? Is that a good idea? Wait a sec. Can we just say the integral of sine z is negative cosine z? Is that legit? I think we can do that.
It's analytic. Isn't this a closed path?
Well, it isn't just 0 again?
Yeah.
It's going to be 0 again.
Okay, maybe we should also do B. This is just lame. B has a non-analytic point or branch, whatever. I assume it's gonna. I wonder. It's not a smooth contour, so that could be something interesting. Besides just like 2 pi I or whatever, like the same thing as it would be for a circle.
I bet you it is 2 pi I.
Okay. Well, I would think for what we can just let z equals x plus iy, and for each one of these paths, one of x or y will be constant, so it should be easy enough.
Okay.
So C1, C2, C3, C4. So starting with C1.
So for C1, you got x is 1 and dx is 0.
Oh yeah, I should be careful with this. Let me not jump the gun. 1 over 2x plus iy plus 1 times dx plus idy. So yeah, so for C1, x is a constant 1, and then y is varying. Y varies from -1 to +1. Dx is 0. Someone's calling ipi. Dev is calling 0. X is always 1. That's the C1. And then for C2, hey Colorcone, hey Suna. It'll be from 1 to -1, 1 over 2 x plus I plus 1 dx. That's going well. How about you? Dev, the contour isn't smooth though. So I would have to look at the theorems again for how they apply, but I think they usually want smooth contours. I think.
I thought it could just be piecewise smooth.
Oh, you're right. Yeah, so maybe 0 is a good call.
Well, this time we're going around. If we're doing part B, though, I think for part A, it's going to be 0.
For part
But
A
I
is
still think-
0. Oh, this is an analytic, right?
Yeah.
We're doing complex integrals, and Green's theorem is related. We're not using it here, though. So wait, for C3, x is -1. Okay, and then finally, for C4, y is -1. We're going from -1 to +1. X minus I plus 1 dx. Okay, those are the integrals.
Okay.
Not everyday dev, no.
Could we pair them up in a clever way, like pair these up and pair these up?
That would be nice if we can just say that they cancel somehow. Oh, they don't. They probably don't cancel.
They might not cancel, but if you pair them up and get common denominators, maybe, is that a good idea? Or should we just do a bunch of logs?
Let's see how it looks, because we'll have to reverse the order for the second one, but that's fine. Hey, Scorpra, it's been a minute. 3 plus 2iy minus 1 over -1 plus 2iy dy. Oh my.
IDY.
Oh, thank you. I should write parentheses. On the last question we did was question 2. Oh. Was it? Oh my god, it was question 2. That's why. That's again, hey, questions 1. You're right, Lubert.
Oh, was it the wrong answer?
Yeah, so the 1 over z conjugate, we were probably right. Oh my god, thank you, Lubert. Okay, I'm gonna say these are probably easier to integrate on their own rather than getting a complex or getting common denominator.
Okay.
Because they're just
Yep.
ln's, right? Plus.
Yep.
No, I don't want to rewrite all that. Let's just see how these. We're gonna get 1 over 2i ln 3 plus 2iy. Minus 1 over 2i ln minus 1 plus 2iy. or minus 1 to 1 plus, just mirroring that with the x's.
We still got this I, so why don't I just cancel those i's?
True. Yeah. Thank you. Okay, so that one is the negative one. Nope. 1/2 ln 2x plus 1 plus 2I from minus. Actually, you know what? I can just do that. Plus 1/2 ln 2x plus 1 minus I from minus 1 to 1. Okay. This is a really annoying answer. I was kind of hoping it would look nicer, but it doesn't seem like it's going to be very nice. We'll frame it. I probably should have. That'd still be a pain to type into Wolfram, but it would be easier than this.
Just some giant logarithm.
Yeah, okay. I was hoping we get something a little more reasonable. Integral plus, should maybe just do one integral at a time. Y. Oh wait, definite. Okay, the first integral is minus 1 to 1. Over 3 plus 2iy. 3 plus 2iy with an I. It's just something disgusting. So let's get the other integral also added in. Negative 1 plus 2i. 2iy. It's still disgusting. I was hoping for some cool simplification here. So far I feel pretty cheated. One to minus 1.
Oh, there's a 2 missing over here.
Ooh, where?
Right at the end. Right over here.
I don't see where you're. Oh wait, keep pointing again. Oh.
Dang it.
Oh, the I should have a 2. You're right.
Yeah, right there.
One over 2x plus I plus 1. 1 over 2x plus I plus 1. One less integral to type in. 1 over 2x minus I. Flip the bounds. Don't forget that. Oops.
Log A plus log B.
It's just stupid. Oh wait, it's pi I or I pi.
The whole thing's just pi I.
Yeah, it's pretty painful to get to that
Somebody said that.
place.
I thought Slim said that.
Yeah, Slim did call it. Huh. You just have to. So painful. That's an exercise for the reader to actually get IPy out of that math. I wonder if there's a quicker way of doing that.
There must be. Slim's got a secret.
Oh, yeah. Okay. For now, I'm just gonna move on to the next one. I was saying just A for this one. How can you figure out using Cauchy residue theorem? Ooh, okay. Oh! Gave me your thermodynamics for chemistry? Oh my god, good luck. I'm doing well, though. Okay, you know what, Slim, you're asking a good question here.
Oh, it's 1/2 of 2 pi I. Is that how you got it? Yeah, because there was a 2 on the z, right? You factor out the 2 and you get 2 times z minus 1/2. Or z plus 1/2. Yeah, okay, I think I get it.
F of zeta is zeta minus z. Yeah, we have to rewrite this integral somehow.
I think you just factor out the 1/2, so it's 1/2 times integral of 1 over z plus 1/2.
Oh, and then okay, so we just need a function zeta that doubles it. Is that what we're saying? No, zetas are terrible. Zeta. Oh wait, no, we need a negative sign. Wait, no, I'm thinking of the f of zeta wrong.
So 1? No.
Wouldn't I draw a negative 1/2 to get the negative with the z? Really? The thing that trips me up with this is that f of z should match f of zeta. just with a different variable. Oh. Is it just the same thing though? Because negative a half. No, that gives us 0. Bruh.
What about this? Tell me what you think of this. 1/2 integral 1 over z plus a half 1/2 log and this is over the contour, right? So if I go around the unit circle now, right? So this is on the unit circle. Then doesn't the ln of z plus a half, doesn't that just give me 2 pi I because I've gone one time around the log,
Oh,
around the branch point or whatever?
that's the quick way of doing this, isn't it?
Well, it's quick, but if it's not right, then it's no good.
I think it's fine because log is analytic. It's the same as the residue theorem.
Same as the residue theorem. What I want to know is how all these crazy things we had over here were going to turn into pi times I.
I mean, at some point we're gonna have to use the like log identities to, or well, I don't, I don't know. We'd have to rationalize it, convert it to a polar number, and then do the log identity stuff. It would have taken a long time. Bobos, hello. I don't know.
How you doing, Phobos?
Oh my god, we're almost at 2 hours and we haven't even gone through section 2.4.
All right, you want to go to the next one?
Yeah, let's just like talk about number 4 and then we'll move to like
Yeah.
question for the next one. Use a principal branch of log z and z to the 1/2 to evaluate this. I bet we could treat that as just the integral of a normal log. Is this basically a Calc 1 question? I mean, we could do like a polar substitution too. Warm and moist, nice. Maybe they want us to do polar, but I bet you could say the integral of this thing will be like z ln or z log z minus z. But I'm not completely sold on that. And I think we'd say z equals r. It would be e to the I theta, but theta is constant 0, which is the same as choosing the principal branch of the log.
So when they say integral from -1 to 1 dz, what does that mean? We're supposed to go along a straight line, or can we go any way we want? Because we better not go along a straight line because we'd go right through 0.
Oh. That's what I was about to do. Yeah, log 0 is bad. So what if we integrated around like a semicircle? Well,
Yeah, sounds good.
maybe the other way is more intuitive. In which case we would take z equal to the I theta. Don't make the same mistake for like the 5th time in a row.
Now, principal branch. What is the principal branch? Is that from 0 to 2 pi?
Yeah.
Okay.
I'm doubting that whether I should include 2 pi here now, though.
I think it's good.
We'll see what we get, I guess. What am I doing? Z equals e to the I theta. So log of e to the I theta is just I theta. Which I guess is going to be integration by parts.
Yuck.
Nana, this is complex analysis. We're at the end of chapter 2 of a book, so we're still pretty early on. We're talking about complex integration. Okay. U is theta, dv is e to the I theta d theta. du is d theta, v is I e to the I theta d theta. Nope. It's 1 over I. Okay, so that I times that I gives us a negative. 1 over I is negative I. So I'm gonna make a sign mistake. So we have a negative on the outside, and then a negative I theta e to the I theta minus v du. But then that 1 over I, it's just a negative I. Okay.
Okay.
I theta e to the I theta plus e to the I theta from pi to 2 pi. We're just talking about complex integration. We like kind of just got to Cauchy's theorem and Cauchy's integral formula. No. That's a minus. I think that's right.
You could factor out that e to the I theta if it would help. Maybe it doesn't really.
I'm kind of leery of getting a 2 pi in the answer. If we go from 0 to pi, wouldn't we be getting a different answer? I guess from pi to 0.
Oh.
I want to back
Okay.
up and change my bounds, yeah. So I want to integrate along, I guess, the upper half circle. How is this curve? Okay, see you, mouse. You get the same answer? Really? Okay, I'm trusting Slim. Because I don't feel like going back. 2 pi I, because that's 1, minus 1, minus I pi e to the I pi is -1 minus -1 is +1. How does this clean up? 3 pi I minus 2? Question mark?
Okay.
There's no way the same thing from I theta e to the I theta. It should be I pi? Do I not know how to do math? Did I mess with the integration by parts? That's always possible.
I didn't see anything wrong.
-2 plus pi I is what I get if I go from pi to 0. Ugh, okay. I think Wolfram agrees with the result of the integral.
Okay.
So what the hell?
I just tried it a dumb way, and I got I pi -1. I pi
Okay, so
-2 you
we
got
have
over
3 different answers now.
there.
-2 plus 3i pi for pi to 2 pi. Or from pi to 0, we get -2 plus I pi. I feel better about the integral from pi to 0. Because I think once we include 2 pi, we're crossing a branch. That just
Maybe
feels bad.
If you're going clockwise, then maybe your dz has to have a negative sign on it because the d theta would be. I feel like one way you're going to have a negative popping out somewhere on your dz term. dz d theta. But I'm not sure.
What if I just give the integral to, will form alpha know how to do it? If I just say the actual origin problem,
Maybe.
-1 to 1 log z
Maybe.
dz -2 plus I pi. That's the answer that I liked from pi to 0.
Okay.
So why shouldn't your thing get the same answer?
Oh yeah, sorry, I got a mistake.
Oh,
here.
you have a mistake.
This is not
Okay.
a 0. This is a minus. This is a -1. This first one. That's a mistake. Yeah, because when I plug 1 in, I don't get 0. I get -1. I get 1 times 0 minus 1. That's -1.
Okay. Yeah, I feel a lot better about this. Pi to 0 makes more sense to me. And then I think your solution is just even better, but well, yeah, maybe, probably.
So wait a second. I pi -2. I pi -2. The other one got 3 I pi -2. So we're out by 2 pi I. Yeah,
That makes
maybe that's
sense.
something to do with the principal
Yeah.
branch.
Or I would think so, yeah. Because once you cross a branch cut, you're off by
Maybe
2 pi I.
Yeah, maybe somehow that first way you did it was crossing a branch cut somewhere.
Yeah,
Well, you
I
did
mean,
say you didn't like using 2 pi, right? If you change that 2 pi to a 0, would that have just fixed it?
yeah.
Yeah, because it would have made this term 0, wouldn't it, right here?
Uh,
And everything else would be the same,
yeah.
I think. Okay, that explains it. So maybe the branch cut. So what's the branch cut? 0 less than equal to theta
Mm-hmm.
less than 2 pi, right?
Yeah, that's why I like pi to 0 more.
That's the principal branch, maybe.
Mm-hmm. Branch cuts in action.
Hmm.
And then drag over the better work. Okay.
What time is it? You want to keep going or no? What's the next question you were looking at?
Well, I had one
Probably
more from
something hard.
2.4. It is a harder one. I think maybe let's do a question from 2.5 if you have time, and we can just call it good.
Sure.
Okay. Hey, Anirud. And hey, Bubba. I'm definitely going to keep on working on the other ones, like, over the week, but for this one, I said A and C. Imagine the parking lot structure. Walking in the top circle means you're going down. Taking the circle from pi to 2 pi means you're walking uphill. Yeah.
Hmm.
Or it's like once you get to the 2 pi, it's like you're on a new floor. If you stay from pi to 0, you stay on the same floor. So this is from 2.5.
Why does this look like the same thing we just did?
It is basically the same instructions. But now we know if the thing we're integrating is analytic, then for a simple closed contour. So A should just be 0, right? Because e to the z is analytic.
I'm just looking at the very first question we did tonight, and it looks like the same question. I mean, I'm sure it's not. I'm sure it's not identical, but I mean, it's the same idea. It's the same basic premise.
Yeah, I had the same
Closed integral
thing when I was choosing questions. Honestly, we could just do a different one, but I think that the difference was that we now have Cauchy's theorem to think about these things with.
Yeah, we got the superpower.
Yeah.
Yeah. So what does that mean? A is 0 and C is 2 pi I.
Yeah. Okay. Well, that was maybe a little too quick.
Does that seem right? I think it's right.
That's what I would say. Yeah. Okay.
What about E?
E.
If we factor out a 2, we get z squared plus a half, which is z plus minus I over root 2. So there'd be 2.
Ooh. So we have 2. Oh wait. Yeah. Where is it not analytic? At I over root 2 plus or minus.
I think so. Yeah. So those are probably both inside the unit circle.
So should this be 1 over 2 pi I times 2?
I think it's just 2 pi I times 2.
Oh. Yeah.
We got, oh no,
Oh no.
Undo. Sorry.
It's all good.
Yeah, this. Unit circle. 2 over 2.
Fuck Laura, just practice. I think the justification for this is that like figure we looked at with like n different and like analytic or non-analytic points, and the integral around the entire contour is equal to the sum of the contours around those non-analytic points. And for each of those, we just get 2 pi I.
Yeah. Yeah, I think so. So we'd have to do something like this, like come in here and come in here.
Yeah.
Okay. Cool.
Nice. I guess we can call there. I only pulled one other from this section, but there's like a part A, B, and C, or A through D that I'd want to do all of for that one, so it might be a little bit too long. Another few from 2.6. Ugh, we're leaving a lot behind here. What is the pacing like? I want to get through 2 more chapters.
How much time have you got?
That's what I'm trying to gauge. I don't have a date yet for when I'm going to actually move. But I'm thinking like I probably want to do it late July or early August. So I think we need to keep on moving through the book.
Yeah.
Uh,
I mean, the book seems to be going quickly to me, but
yeah. There's like a couple of points I have to get, like, where I have to read it a few times and like work some stuff out on paper, but it's not too bad of a read.
I was reading that that big engineering math book I got by Kreisig that I used at college.
Oh yeah.
I was looking at that a little today, and he was going through some of the same theorems that are in this book. In fact, he did that same theorem where he wrote where he was trying to find the antiderivative function. If you knew that your function was analytic, that you could prove that on some domain you could find an antiderivative. And
Oh
he had
yeah.
the same kind of picture where he drew like another where he defined the capital F as the integral from a fixed point up to z. Anyway, but there's tons of like problems in that book, so I think I'm gonna have to grind some of them.
Okay.
Just do lots of complex integrals. That would be my recommendation. Maybe
Yeah,
I'll
same.
take a photo of the problems and post them in the Discord, and you can look at some of them.
Yeah, sure. Um, okay, the good news for chapter 3 is that like half of it is starred, so we can just skip over that. So maybe we can say 3.1 and 3.2, which is gonna be like maybe even just 10 pages. That might not be that much reading. Probably a bit, like probably between, sorry, it's probably more like 15 or something, but it shouldn't be like that bad.
Yeah.
Okay.
Yep. Sounds good.
Awesome. Well, thank you for being here.
Yep. Thanks for having me.
Yeah. And I'll talk to you next time.
All right. Yep. See you, Don.
Bye. Okay. Let me get things switched over. Get music going first. What music? I guess we can do lo-fi. Hey, Zach. How's it going? What am I doing? YouTube information. Fine. It's good to hear. Where's that thumbnail? Okay, YouTube's up to date. Yeah, I got some grinding to do also. There we go. Notes for sections 2.4 to 2.6.1. Next week, we'll talk about sections 3.1 and 3.2. Oh, that's not 3.2. That's 3.2. I think that's all I need to say. Oh, I usually do I add the group for these? Apparently I do. Okay. We can close out of that. Close out of that. Keep that. All right, I think we're going to go right back into grinding questions. Oh, this question. I'm not doing anything with that question. This question got a lot of discussion in the Discord server though. What were the other things that I chose to work on today that we didn't have time for? I skipped over one from 2.4, so let's start with that one. Is there... Oh, wait. I forgot to switch the Twitch information, didn't I? That's all I have to do. Okay. So this is from section 2.4. You know, I'm just wondering, with that last question, the integral is independent of path as long as we stay on the same branch, right? So to get from -1 to +1, we chose to follow the unit circle that way around, but we could have done some like stupid path like that if we were masochists, I think. Yeah, that seems reasonable, right? Okay, 0 to b, 1 over z to the 1/2 dz, for b greater than 0. I assume b is real. Wait, the top half of the cut? What? The Bart Simpson's haircut path? uh... It kind of is, yeah. The determinant of a 5 by 5 matrix? Do you have to calculate that by hand? Because that's terrible, Diego. Well, I would probably do there, Diego. It's probably, that's big enough where it's probably better to do row operations before you try to take the determinant to get as many zeros as you can. The only thing to be careful of is if you swap rows or if you multiply a row through by a scalar, that changes the determinant, but it does change it in a predictable way. But if you're forced for some stupid reason to do that by hand, you probably want to do row operations and get as many zeros in that matrix as you can. Okay, so My immediate question here, what is the top half of a horizontal line? What don't I get here? Semicircles? Maybe. Had a sprinkle of mind twister? I guess so, noob driver. Uh, yeah, the circle will be a little bit harder to define, but we sure can. Um, minus b to b. That's also, I was wondering about that too, Slim. Like, I was assuming we'd imagine it as a limit. Uh, I mean, okay, so this is from section 2.4. We know it has an analytic antiderivative. That's not what I wanted to. Uh, can we just do that and not worry about it? Well, that doesn't say anything about the branch cuts is the issue. Oh my god. I've been on red for a long time. Let's go purple. What's the condition to use that thing again? Oh, frickin' continuity. I'm wrong. Oh, we're back. Damn, Zach. You outplayed me. Hey, Najaf. Thank you for the kind words. Hope you're doing well. Well, that's just a problem. Do a Minesweeper? Ooh, it's been a minute since someone has redeemed that. Okay, be careful. Don't go so fast that you misclick. No, it's so tempting to go as fast as you can, but just don't do it. It's not worth it. Fuck! I gotta go for the WR? I do. Damn. Sorry. I was really into it. I just spaced out for that one click. Oh, I misclicked on that one. I'll get it. Was I doing easy before? I feel like I was doing these way faster the last time I did one. Like 40 seconds or something. Maybe I'm just getting old and slow. Uh, there we go. Oh, wait, 40 seconds. Never mind. That was a decent one. Thanks for the redeem. Show. Okay, so I wonder if someone's right and there's a typo. Can I just try to assume there's not a typo and see if I run into something though? Uh, so this is annoying. This is going to depend on. It's not going to be a constant R. R. I mean, we could always translate it. Ooh. Ooh. What about that? What do we think about that? Am I translating it the right way? Yeah. Let's see what we get. Um, oh, ha. Thank you. May as well factor that bad boy out then. Uh, does this equality need justifying? Why can't I just say this? Like, why shouldn't the path matter here? I don't know. I'm just gonna go with it because I don't feel like trying to figure out why. Wait. This is the use of that I want to do, but aren't I just gonna get that? But with you? I guess it's in a new context. I feel like I've done something sketchy here. And I did not bring my sketchers for this. We'll just see what answer gets spat out, though. Minus b plus b over 2. Nope. Plus b minus b plus b. Well, that's not good. Wait, yes. Maybe? Can you repeat that question? You're not the boss of me now? Minus 2b? And then if we took this same thing and made the bounds pi to 2 pi, isn't this going to be the same thing that we just did in that one problem? Whoa. Did I actually do it right? I feel like I did something really weird. When I did this. Like, something that's unnecessary that's confusing me now. Like, I feel like I should have been able to go from that directly. Like, I should have been able to integrate this directly and then make it polar. So I don't know if this is a very clean solution, but it ends up with the thing, like with the desired result. And when for the question here, do they want, like, the difference is 4b? Is that what they want? Or like, I interpreted the word difference as in subtraction. But I don't know if they mean, like, difference in the normal English meaning rather than the math meaning. Fuck it, dude. I don't know. I'm calling that good. This is from 2.5. One point 2.19. It was that one. Okay. Um. Ooh, I think this will be a pretty instructive question. Uh, where was the annulus? Which that. That's why we want to break it up here. Well, okay. That way. That way. C1, C2. So the integral around C is going to be equal to the integral around C1. Oh, they start counting from 0? Wait, what? Oh my god. I was wondering why my numbers were going to be off, and I just realized they start counting from 0, like they're a frickin' computer scientist. Unbelievable. Okay. Um, how do we actually integrate this thing? Probably use this idea. Oh, okay, for the first one, for the first part, we're not enclosing any danger points. So the first one should just be 0. I am going to need this for part B, so we'll just shove that away. But we're not... Between 1 and 3, there are no non-analytic points. Simply like those crazy logs for the integral from the square problem we did, they all canceled out to 0. One of the 4 sides went through a branch cut. Oh my god. That is crazy, Femlux. I can't believe you actually went through and did that. I have 0 desire. So you got pi times that the other way, yeah. So B... this isn't even right. We need... We have an issue at z equals pi. Right over yonder. So how do the cross cuts work here? And we just have a typical cross cut right there. I think... What do I think? I think C0... I think C0 would get deformed. Into C2. And I feel like we would end up with something like this. I'm going to draw some arrows on this because it's looking a little phallic. We need to traverse it other way. I'm not I'm not the most confident. I think I'm saying that C0 is going to be equal to minus C2. And so I get this. Maybe I should do this in 2 stages. That's how I'm thinking about this. I hope it's right. I don't know if it's right. Also, how do we actually integrate this? We need to use a series, apparently. The z minus pi part is kind of annoying as hell, though. Can you do partial fractions with variables in the numerator? Oh, that's worth investigating. Okay. I I'm getting nowhere after this. I don't know what I don't know what to do after that. Um. Oh wait, there's an I. If I, it's e to the iz. I did this wrong. It's more like that. This is getting more and more stupid by the second. And this problem is from 2.5. Is it? It is. But that would be a good shout. No, never mind. Um, z minus a is re to the I theta. They're saying r is constant and very small. Not in love with any of this, but shove that down. Shove that down. I don't pay for any streaming service because they've been slowly becoming scams over the past like 5 years. If you have something that you're watching though, I'm interested to hear what it is though. Okay, so they have ads now? Netflix does? Man, I thought Netflix would be one of the good ones. Partial fractions to get an analytic function and Disney Plus? That's ridiculous. I don't know what I'm doing partial fractions for. I'm getting partial fractions to get something that's possible to integrate, I guess. Someone's better with their ads. Sometimes just have some before a movie, none during it. I just saw an article saying they sneakily increased the number of ads like last week. Oh, but it, like the path of a lot of things in tech, they're just going to gradually make it worse and worse and worse for the consumer. And if we're lucky, eventually some disruptor come out with a new product that's way better, and then that'll get worse and worse and worse, and then someone will disrupt them. But it's like a 20-year cycle or something. And so we had our golden years when everything was just on Netflix, and Netflix was only $8 a month, and we're not going to have times like that again for a long time. WhatsApp is a massive thing, though. I'm not surprised that they're cashing in, and they're owned by Facebook. Make something better was there before. Once it was popular, make it bad again for profit. Yep. I'm waiting for Discord to do that same thing. It's been holding out better than I thought. But I think Discord is going to go down that path too. I already really hate their system with server boosts. They lock pretty basic features behind very high prices, but they spread it out among multiple people, so it doesn't seem that bad. But if you add up what they're charging for like a custom link, it's kind of stupid. I don't know. Nothing ever lasts. What was the idea? Someone pay for it? Oh yeah, like I'm not saying it's not it I'm not saying it's not worth it, I guess, for some people to pay for it depending on their situation, but I don't know. It's just a sneaky way to get more money out of people. We're taking R to be a very small constant here. Same with this. We're gonna get e to the e, and that's just going to be life. I don't know how to take derivatives. um oh, you know what? The fun thing is that that's also going to happen with cars. People are going to try and make the cars like smarter and smarter because they're going to find ways to charge people for those smart features. And I really I don't want smart features in my car. I don't want an iPad in in the middle. But that's just going to be the way of the future, and that's what everyone is going to make at some point. E to the I R E to the I theta. What a thing to integrate. Oh, yeah, I'm sorry, Fenvox. You were just trying to recommend something. Barbarian, okay. I went on a whole rant there. That, sorry. Um, oh yeah, I heard about that, Slim. I I'm definitely not opposed to certain methods of watching shows. I'm not being really precise here. These aren't contour integrals anymore. Uh, 0 to 2 pi. I didn't deal with C1. We deal with C1 in the exact same way though, don't we? Is that right? Like, well, no, it's wait. Oh, this is C2. Wait. Um, C2 is the one that's over there. Don't I need to offset where it's located at pi. So isn't this really z minus pi plus pi? Or like, I guess, like this right here is the point z equals pi, is what I'm trying to get at. I hate this. Like I want to do re to the I theta plus pi to express that we're centered at pi and we're doing a little circle around it for C2. But that doesn't really make this integral any simpler now. Oh, wait. What if I just said z equals re to the I theta plus pi? Maybe the original thing I wrote was okay. But then this over here would need a plus pi, and I don't like that. Um, what do I do with that? I really hate that. Am I thinking about this right? Well, maybe I'm not. Should I think of it as the radius not being constant? Hey, Fizzbuzz. Going around the pool of 1 over z, like, yeah. What is that emote? I need to zoom in. Just a rat spinning. I feel like the answer to this is going to be something pretty simple. I'm struggling to justify it. Oh, wait. Are you guys waiting? I don't think you guys are waiting. Okay. This is analytic around C2. It doesn't, the only non-analytic point for that piece is 0, and C2 doesn't surround 0. That's just 0. Okay. Oh, Yeah. Yes. And I think we'll make the same claim for C1 for the part with pi. Okay. Oops. Okay. It's a good thing. So let me change up my color coding. Blue will be for zeros because 0 is cold and blue is cold. RE to the I theta, DZ is R, IR e to the I theta, D theta. Oh. I messed that up, didn't I? With this. That's just gonna be a -1 though. That's okay. E to the I R e to the I theta over pi R e to the I theta times I R e to the I theta d theta. Okay. This is certainly a thing. I cannot say it is not a thing. We can factor out a -1 or minus I over pi. Ooh, that's fun to say. Minus I over pi. What do you mean, Papadoria? This is too many RE to the I thetas. You must not enjoy complex numbers, okay? This isn't enough. E to the IR thetas for me. And I'm gonna power series that dude. We'll have an I and an no, we won't. J equals 0 to infinity. I R E to the I theta to the J over J factorial D theta. Quaternions greater than complex numbers. Oh, hey, these are becoming the same integral. Ooh, wait, whoa, 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 whoa. Whoa, 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 whoa. It's minus C2 in minus C1. I need to flip the bounds or add minus signs. I'm gonna add minus signs. I'm just gonna flip the signs of everything. Okay, complex numbers have much more use cases, but quaternions weirdly enough are useful in 3D rotation, so why not? I've heard that. Yeah, that like they're using like computer image, like physics engines for rendering stuff. Don't look now. I think I heard Merryweather. Boom, 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 boom. Okay, these are collapsing into one integral. That's nice. It's a good thing. Oh. No, I shouldn't wish that they would cancel to 0. I don't expect them to be 0. I don't expect the result of this to be 0, I should say. What are we doing with this shit, though? R is very small. Surely we're going to chop off. I don't know what we chop off. Wait, can we just integrate it term by term? Well, we're integrating in theta. Oh. Yeah. If we can swap, pull little swapsy-doos. Like this. I think we would be in business. Is uniform convergence the condition where that's allowed? Because e to the z. Yeah, I was gonna figure that a sum of e's should be nice enough. I do remember learning about uniform convergence. That was my first time learning about it. It's super weird. It kind of makes sense, like what it's getting at, though. What am I doing? Integrating in theta. I r e to the I theta to the power of j over j factorial times 1 over ij? Which is the name of a pistol in DayZ. But, you know, who cares? I feel like I'm... If I did this right on the first... Or, I mean, if this counts as a first try, if I get the right answer out of this, I'm going to be kind of shocked. I doubt the book is going to list the answer, because the book just doesn't list the answer for anything. Oh, you know what? I'm going to cancel that I and that I. Because I can. So what's happening? When theta equals 2 pi, e to the 2i pi, we get Zach. That's 1. I r to the j over j factorial. A minus, well, oh no. E to the 0 is also 1. don't expect 0. Wait. Ah, these are different thetas. Oh my god. I need to back up. I use theta twice, and I confused myself. Bruh. Okay. I need to delete Zach. Just use Ninja, it's fine. True. Okay. Um 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 I guess I need to do the same idea, except okay, yeah, from here I do a swap skidoodle for just those two. I'm sure swap skidoodle is the mathematical term for what's happening here. I don't feel like writing that. Okay, this thing integrates to I r e to the I theta to the j over j factorial times 1 over ij. Again, gonna run to the store before they close. Sounds good, Fenlux. Yeah, I probably shouldn't go for too much longer. I'm just hoping I can get to the end of this problem. But yeah, thanks for being there for the complex analysis. Good luck with the store run. And then that'll look the exact same, so I don't feel like writing it. The I can cancel the I. I'm probably going to forget that it canceled. J equals 0 to infinity. Now, this... You have the new Ghost CD in your car? Hell yeah. Okay. R e to the theta is z minus pi. So I, z minus pi to the j over j factorial times j plus j equals 0 to infinity I z to the j over j factorial j. This seems promising. Hear something out your window, just you cranking it? Oh my god, if I can hear you from California, you must be really cranking it. Oh wait. Oh, this J is ruining my life. My life was going fantastic until I saw that J was there. Yeah, sure, Papadoria. Feel free to to post it. I might not get this one quickly, so if you want, just go ahead and post yours because otherwise you could be waiting for a while. Oh no, I thought we were gonna get an e to the I z minus pi and an e to the I z. Wait, no, what am I? We have bounds. These are definite integrals. No, wait, was it actually okay? I don't know. You already wrote, oh, let me see. Let A be a sequence such that a sub I times a sub I minus, or times a sub I plus 1 equals I. Really? For all I in natural numbers. Oh my god, I this is bad to go from a complex analysis problem to a sequence problem because these I's are looking all sorts of strange to me. Final limit n goes to infinity of a sub n over a sub n plus 1. Isn't this... Yeah, sequence of complex indices. Like a two-dimensional sequence? Someone has to have defined that at some point, right? Can't we say that a sub n plus 1 is equal to n over a sub n? 1i, 1i. But I think this is the actual... I think this I is a variable. Or like, it's also the index. Or... Yeah, so this is a question from Papadoria in the YouTube chat. So this is completely unrelated to the stuff I was just doing. I think this means like a sub 1 times a sub 2 equals 1. a2, a3 equals 2. Okay, yeah, Papadora's can... I did the same thing, Zach. Yeah. Now, can you explain how the law of cosines works? I can explain how to use it. Do you mean like how to prove it, or just like how should you use it to solve a problem? It is a thing? Oh my god. Oh yeah, well, oh, like a sequence of complex numbers, I can get that, yeah. I was getting confused, especially with like this being the imaginary number I as an index and like being able to like a sub 1 plus I or something. Yeah. A complex sequence is just like the indices are still like natural numbers. Like you might have n a sub n. It could be like I don't know, just like maybe a simple example like 1 plus I, 2 plus 2i. Like you could have a sequence like that. That's fine. Oh, a sub n squared. Thank you. Sure, the absolute value of a sub n is bounded. Ooh, okay. No, I mean, maybe that does Papadori, but that'd be some weird uh niche thing that someone did for fun, probably. 1 plus 1, 2. This is a grade 10. This is probably like university undergraduate. Squeeze theorem? Really? Um, we want to squeeze it. So can we say 0 is less than or equal to a sub I is less than or equal to a sub I plus 1? Error, let's not go there, please. Uh, I don't know, Papadoria. I wish it didn't. Don't say that yet. For the thing that you were saying? Okay. This isn't the right choice of upper bound. That won't squeeze right. This feels like it's a weird way of saying it's a geometric progression. Well, no, and no, it's not necessarily. It could be like a Fibonacci thing where it's approaching some ratio. Ooh, wait. Zach is saying 2 over x is less than x when 2 is less than x squared. Oh, that doesn't really work, does it? I'm gonna have to work on that another time. I'll put the chat back up on screen in a little bit. You have the answer to it. I have yet to look at it. But if there is, it is there if you only check the answers. More importantly, the derivation of the answer is what I'm curious about. It'd be nice to figure this out. Oh wait, you know what? Yeah, Slim, that's probably like A should always be more than 1 each of these terms. Is that true? Does that seem reasonable? I think so. Like, wouldn't this give us a good squeeze? That's not true. Can we say it's true for a large enough I? I need to like it's hard to think of this without an example. So A1, A2 is 1. A2, A3 is 2, A3, A4 is 3. This is like a system of infinite equations with infinite unknowns. So we can solve it because there's the same amount, right? I'm trying to think of what these numbers would have to look like. Yeah, Papadori. Okay, let's see. Is it safe to bring back the chat? Okay. Oh, yeah, okay. We can just pick an A1. Nishal, are you doing that? What are the bounds for that integral? That's called the Gaussian integral. There's a couple of ways to solve that, assuming it's from minus infinity to positive infinity. I only know the polar coordinates way. I think there's other ways of doing it. Like, you can probably use series too. So if A1 is 1, A2 is 1, A3 is 2, A4 is 3 over 2, A5 8 over 3? That's kind of trippy. I think it's going to always be more than 1 with this choice of A. Sure feels like it. Like, if we can justify this, we're basically done. So what if I pick a fractional? Like, what if I pick A1 is 1/2? A3 is 1. Oh. No. A4 is 3. A5 is 4/3. For a second, I thought I was gonna like loop into this one, but it's not. Okay, it seems like it's just kind of gonna be monotonically increasing. I don't expect that to ever stop. Like, the fact that the right side is always increasing is going to ensure that the next term is always increasing too, I think. I think. Now, what if I do the reverse? What if I pick A1 is 5? Let's start high. Shoot for the stars. A2 is 1/5. A3 is 10. A3 is a big boy. A4. Oh no. Wah, 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 wah. 3 over 10. But if you keep on going, I bet it's going to only increase. See, we're back at 40 over 3, I think. Yeah. What if A1 is negative? Oh, yeah, I guess we're doing the absolute value anyway. It's hard for me to justify this mathematically, but it seems like, or my feeling is that no matter what your choice of A is, there should be some cutoff point where you're always going to be increasing. You might initially have some fluctuations, but in the long run, you should be strictly increasing. You found something interesting. Okay. Is there an inductive approach to prove it? Ooh, maybe. We need to state this in a more exact way. Oh, Zach. Huh. I didn't even think of doing that. Yeah, is that the double bang? Or what do you call it? The double factorial? Where if you give it an even number, you only do the evens. If you give an odd number, you only give it the odds. Yeah. So in general, a sub n minus 1 double factorial a sub 1. Oh, yeah, we do need to make it. Oh, it's not as simple as I hoped. But Slim is saying there's going to be a lot of cancellations when we divide. Ooh. Why is a sub 1 squared? Oh, a sub 1 is flipping up and down? I didn't catch that. Yeah, that makes sense why it's flipping. So wait, let me write out what exactly Zach said a sub n is. 2n minus 1 double factorial squared divided by 2n double factorial 2n minus 2 double factorial a sub 1 squared. What the heck? Well, Slim makes a good point where if we just plug this baby right in there, we're going to get a bunch of cancellations. It's going to be a limit that we can do. I'm just trying to understand this formula for myself. Why is a sub 1 squared and always on the bottom? If it's flipping. Two n minus 2. I feel like we need like... Don't we need some kind of power on the outside with like that controls the sign? Or like that controls which way it's flipped? Like a -1 to the n? I know, I have a hard time understanding that formula. It might be right, I don't know. Papadori's asking about the derivation. I don't know if that's something you can easily share, but I don't think I understand it either. You're guessing it approaches 1 over a1 squared. Okay. Honestly, I'm gonna put the... And so we could theoretically... I assume it would be okay if we made a sequence of just the evens and just the odds and show that they both get the same result. That might simplify it. Once a gamer saying 1 over root 2? Maybe. Oh, nice. Papadori posted it in the math discussion channel. He's a electrified rubber band. Here's your scribbles. Yeah. Some scribbles are better than no scribbles. Norg 98 times 7. Well, if you're doing that by hand and not using a calculator, I would set it up like that. In the first task is to do 7 times 8. That is 56. And now we do 9 times 7, which is 63. But then you add 5 from the 5 that we carried over. So 63 plus 5 is 68. So I'd say 686. Take the common ratio, apply basic GP formulas? Maybe? I don't know. No worries, Nord. Yeah, it isn't necessarily a GP. That's a good point, Papadoria. In fact, it's certainly not a GP. Because the ratio isn't constant. Wait, I messed something up here. That's a 3. There we go. That makes more sense. Oh wait. Uh that doesn't exclude geometric progression, right? Inherently? Or it's not trivial. This doesn't necessarily say anything about the ratio of terms. It might, I don't know. Um My idea was to make a sequence for the evens and a separate sequence for the odds. Um like that's not too difficult, right? This I guess this doesn't really prove finding two convergent subsequences doesn't prove the convergence of the entire thing, right? But this would certainly give us this isn't nothing, I feel like, at least. um Wait, I'm like that? I'm getting confused on how to do the 2n plus 2 part. Everywhere where you see 2n, plug in n 2n plus 2? I think that's n plus... Uh... It has to be n plus 2. I'm really not certain about that n plus 2. Yeah, I just don't know. This would give us a constant though. How about this? The coefficient of that n is almost certainly 1, and that's the thing that's going to actually matter for the limit. Made it home. Oh yeah, nice. We're working on a Papadoria problem. I'll show in a second. Oops, no. So I got a half from my thing. So the problem's up there at the top. Deceptively difficult sequence problem, which is pretty on brand for Papadoria. The original idea from Zach was to try and use squeeze theorem. And I think there might be a way, but it's hard to justify. I think this is how you would set it up, but it's hard to justify this inequality thoroughly. I think it is true. It's just you need a high enough I. Yeah, true, Penbox. Invictus is like undergraduate math. It's a challenge problem though, for sure. It is posted in Discord as well. I was like, you're doing it on the Blackboard. Yeah, Papadoria, if you pop into Zach's stream on Twitch, like you can see him working out problems on that chalkboard. Professor's bonus questions are always random but tough. Yeah. And so after we gave up on squeeze theorem, Zach found apparently this crazy formula for a sub n if you start doing substitutions, getting things in terms of a sub 1. I didn't look through his derivation or like through his like scratch work, but my idea to avoid having to understand this formula was to split it up by evens and odds and look at those two subsequences and hope the limits agree. So that's what I've been doing right now. Yeah, Papadoria. Let me grab his link since I know that you do sometimes pop over to Twitch. Actually, Zach is he's mentioned that he's not necessarily gonna do live streams on YouTube, but I'm like, I can't copy this for the life of me. He's gonna start making videos on YouTube. As far as I know, he doesn't plan to do any lives, but he will have a YouTube presence of some kind. All right, let's try my thing with the odd and see if that agrees. Because if I get 1/2 for both things, that would be pretty convincing for what the answer is. It may not be the right justification, but oh, wait, am I messing things up by skipping? Maybe I'm. I hope I'm not. I feel like this is just a change of variables away from being fine and that I shouldn't have to worry about it. But I did just realize these are spaced 2 apart. And the limit in question is only spaced 1 apart. Yeah, if you have infinite time. X equals 12 minus 17? Negative 5? I think that's still negative 5. What did Bob say to my dad? Is that a joke? Like set up to a joke? What? Um, the reputation. The reputation and the actions. 2n plus 1. 2n plus 2. Oh, well, that sucks, doesn't it? I get 1. Ugh. Okay. Reshub, you... I don't have the patience. Okay, so I got 2 different answers, which is not good. I don't know. I think there's something wrong with my approach. Just like fundamentally wrong. I think splitting it with evens and odds, it can't give the ratio the question is looking for. Because I'm skipping by 2s, and the ratio only skips by 1. I'm ready to see the answer personally. Fibonacci is showing up? Is he? Yeah, if you want, you can DM it to me, or you can post it with like a spoiler. I don't know if anyone else is still working on it and would want to avoid them. I mean, honestly, you can just like post it in the math discussion too. Like, if people don't want spoilers, then like don't look, I guess. You just got here? Well, I don't want to stream for that much longer though. It's getting to be dinner time. And my big idea was just kind of wrong, so I I don't feel like going down another path. You don't have to look. Yeah, there you go. I'll give you a warning before I actually show anything. Oh. Okay. Do you have the actual like the work, or do you just know what the answer is? Only the answer. Dang. Hmm. Still think it's a GP? I don't know how you justify that it's a GP from what we're given. It might be. Okay, if I take Zach's crazy thing and I multiply it by a sub n plus 1, do I get n out of it? I think that's the ultimate test, right? To see if that's right. So what happens here? I think nothing's canceling. If you can somehow get, and the a sub 1s certainly aren't canceling. I don't, maybe that's not supposed to work like that. At least the one over a1 squared. Hmm. We were looking at that fembox just to like play around with it. That's what I was doing here. I didn't glean too much out of it. I I, I suspect. Oh no, that's what Zach did here. I can't verify whether it's right or not for myself, but oh, you coded it? So Papadoria did post what the answer should be in the Discord. I'm not going to say whether you're right or wrong. We don't know what the work is. unfortunately. But Papadoria does know what the answer is supposed to be, at least. You were wrong once I gave her? Oh, okay. No worries. Um, once I gamers call a new answer. Dude, I don't know. That is short code. Wow. My state of genuine denial on how to get it. Um, Asia. Okay, let me look at your question. You're given one force is 10 newtons, another force is 20 newtons, and you need to find F2 minus F1. Okay. For for vector subtraction, it's like that, right? I always forget this, but that's what I want. Let me just Google this to make sure I'm not telling you something wrong. Sorry, this is the part with vectors that I always forget how it looks. And I just don't want to tell you the wrong thing here. Okay, yeah. C is A minus B. That's the thing that I wanted. That I wanted. So wait, if C is A minus B, okay, yeah. So I set this up right. Um, unknown, just hang on for a minute. We know that's 60 degrees. So I guess I just law of cosines this. I assume they just want the magnitude, right? So I'd say the magnitude of f2 minus f1 squared is going to be 10 squared plus 20 squared minus 2 times 10 times 20 times cosine 60 degrees. And now just solve this and square root it. So we're going to get 100 plus 400 is 500 minus 400 cosine of 60 degrees. If you don't know that, you can plug it into a calculator. Cosine of 60 is 1/2 though. So 500 minus 200 is 300, and then we need to square root it. Is root 300, and you can simplify square root of 300 to be 10 root 3. Seems like a reasonable enough answer. So I hope that makes sense. Let me know if not. Unknown for vector addition with parallelograms. If you have a vector A and another vector B, you draw it differently. What you do is you complete the parallelogram. So I'm going to take B and repeat it over here. And I'm going to take A and repeat it over here. And A plus B is that diagonal vector there. And sorry, I'll catch up with Twitch chat in a second. Cosine 120, because vector F1 points in the opposite direction. I see what you're saying, and I don't think so, or at least the result of subtraction is just that third side of the triangle. If you wanted to do that 120 thing, you would have to think of it as addition. So you would think of it as like, I'll draw F2 the same way. And then this would be minus F1. So you'd have to do like the parallelogram thing or something, because this would be F2 plus negative F1. And so you would think of this as addition now. Whereas if you just keep them pointing their natural ways, you can do it as subtraction. Yeah, one-side gamer? I don't know if that helps though. Oh yeah, you could do that. Papadoria 306090. Series converges to 1, but only if I let the first term be 1. Otherwise it bounces back and forth between alpha squared and 1 over alpha squared in the long run. Not even be 1. Isn't there a pi hidden in there? I don't know. But yeah, so the reversing the vector thing is valid, but it becomes addition here because you can either do vector subtraction or you can do addition with a negative vector. You'll get the same result either way, but this technique over here wouldn't work. You have to do some other geometry thing. Oh wait, you know what? Okay, wait. If you have vector addition, you do the tip to tail thing, right? So that's minus f1, and then that's the result of f2 plus negative f1. It's going to come out to be the exact same thing. You're going to get back to the 60-degree angle thing. So that way is valid too. But you have to remember to do the tip to tail thing if you're going to do addition. Wallace product? What is the Wallace product? Oh, wait, what? Look how much work we've spent on this problem. So wait, is it? I should be able to multiply those two and get 1, shouldn't I? Or at least some integer? Or do I need to do that times that? Maybe that's it. No, that's not it. I don't see how it's the Wallace product. It doesn't seem to check out with the a sub I times a sub I plus 1. I don't see it. We should be able to do something with, like, shouldn't this times this equal 1 or 2 or 3 or something? It just doesn't. Of a sub n over a sub n plus 1? I don't know. I don't see it. I want to wrap things up. I'm getting tired. Asia. I'll see if I can do yours quickly, but I'm running out of brain power here. Famous tree review algebra. Okay, fair enough. Probably need integrals for this. Well, okay. We don't necessarily need to do this with integration. Well, okay. We'll say minutes, revolutions per minute. And so I want to make a graph of this. So we start at 120 revolutions per minute. Over 10 seconds, we rise up to 720. So that's 10 comma 720. We maintain it for 5 seconds. So 15 comma 720. And then over the next 5 seconds, we go to 0. And so the thing to realize here is that if you take a revolutions per minute times a minute, that's the number of revolutions that you've done. So and if I, in like, okay, but in the easy case, if I take, the answer is it's going to be the area underneath this thing that I've just drawn. And the reason for that is that you can interpret that revolutions per minute times minutes as the area of a square. Like if I want to know what happened between 10 and 15, just get the area of that rectangle there. And the same thing is going to apply to these, even though this is a trapezoid and that's a triangle. We just want the area underneath the curve here. So, or the line. So for 0 to 10, we're going to get, I can't remember the formula for the area of a trapezoid. Can I? Oh yeah, I remember it. The area of a trapezoid is a plus b over 2. So a is 120. B is 720 divided by 2 times the height, which is that distance there, which is 10. So 840 divided by 2 is 420 times 10 is 4200. And then between 10 and 15, that's just a rectangle. The height is 720. The width is 5. And so that's going to be 0, 0, 36. And then between 15 and 20, that's a triangle. So a half times the base of 5 times the height of 720. That's 5 times 360, which is 0, 0, 18. Nice. And now we add all these up, and that's our answer. This is 6,000 plus 3,600, 9,600. Okay, I'm saying it's 9,600 revolutions. Ethan, log base 1 over e square root e cubed. Give me a series. I can do that in a second, Ethan. Solution can't be unique unless we fix A1. Really? So Pablo Doria said the answer was just like one number. It doesn't depend on anything. I'll spoil that much. So I don't know. Maybe I don't know what to say about that. Ethan wants to know about log base 1 over e of square root e cubed. I remember the answer for how you deal with that. I'm trying to remember the justification. Like, I see an e here, and I see 1 over e there, and so I'd like to get it to be a log base e to make life easier. So we should just use the change of base formula, and it should work out. Log base, what I want is log base e of the thing we originally had, and then we divide it by log base e of the old base, 1 over e. That's the change of base formula. And so I'm going to remember that the square root is just a power of 1/2. And so this can be written as e cubed to the power of 1/2. And in the bottom, I'm going to remember that 1 over e is the same as e to the -1. And now just a couple more steps to bring it home. Well, just 2. When you have a power to a power like that, they multiply, so that's e to the 3 over 2. On the bottom, we can evaluate this. The -1 exponent can come out front. That's a log property. I'm going to bring the power out front of that as well. 3 over 2 log base e of e over -1. Log base e of e is just 1 though. So times 1. So on the bottom, we're just going to get a -1. On top, same reason. Log base e of e is 1, so we just get a 3 over 2. 3 over 2 divided by -1 is just negative 3 over 2. So I'd say that's what the answer is. Okay. I want to call it here. I don't have any other ideas for this problem. If you guys don't mind, I hate to cut off the conversation with Papadori and Fembox, but I do want to cut the stream off. It's still posted in the Discord if y'all want to keep talking about it. But yeah, it looks like Fembox posted. I can't quite follow it right now in my like tired state, but it looks like I think Fembox's reasoning was the thing he posted earlier. Hmm. Okay. I mean, hey, a reason why it can't work is also good, I guess. I feel like that should be extra bonus points if you can prove your professor wrong. Okay. If you need the chats, they'll still be like saved in the Twitch VOD. Squeeze out 5 more points. Yeah. But all right. I'm gonna cut the YouTube stream off here. On Twitch, we'll look for a raid. So, Nana's here on YouTube. Thanks for being here.